Okay, so looking at number 1, again, all you're really doing is copying from the notes yesterday, but hopefully you get to the point where you could do this without looking at your notes. I know sine starts at 0, 0, right? Because the sine of 0 is 0. I don't want to go through the whole table of values, but at least I know it starts at 0, 0. I know the period is 2 pi, and I know the basic shape of the thing. So I kind of put all that together. Start at 0, 0, ends at 2 pi, and then I can piece it together from there. And it doesn't say 2 periods, but it does say negative 2 pi to 2 pi. So there's the first one. Let's copy it backward. So we'll put the same picture over here. And there's our graph of sine of x from negative 2 pi to 2 pi. Number 2, cosine from negative 2 pi to 2 pi. Well, cosine starts at 0, 1. It starts at a maximum. And a lot of times on these graphs, I'll start to see things like just a little picture of a parent function. Almost like when you did parabolas. You maybe do a little quick parabola to remind yourself that's what it is. Cosine starts at a max. The max is at 1 until we change it later today. It ends at a max. Halfway in between is a minimum. And then in between there, it's at the 0 or the midline. So there's our first cycle of cosine. And then we continue that backwards. And so there's our first two, our graphs of sine and cosine. Today we're going to start moving them around. So let's grab your notes packet. Notes 2. Translations of trig graph. Amplitude, reflections, horizontal and vertical shifts. Okay, so we're going to move some things around today. Well, we know the graph of sine of x. We just did that one. There it is, just to remind you. This is kind of a weird question because the answer is right here. What do you think the graph of 2 sine x would look like? Oh, don't look at the answer right there. But the graph of 2 sine of x, I think it does, or at least I hope you would figure out that that's what it would look like. So how would you describe the effect of that 2? A stretch. A stretch. Be careful. I would be careful saying it's the new maximum. It is, but if you shifted the whole thing up, the max wouldn't be 2 anymore. So be careful. It's definitely a stretch, and it controls the amplitude. And our amplitude is now 2. And we can move it around a bunch of different places, but that amplitude is still going to be 2. And that's what the next line says. The sine or cosine coefficient affects the amplitude of the graph. For y equals a sine of x or a cosine of x, amplitude is always absolute value of a. Basically, amplitude is never negative. All right, so even if we put a negative a on there, yes, that would flip the graph. That's what this next one is. So it flips it. Let's be careful here. So a is negative 2, little a is negative 2. That flipped the graph, but amplitude is still 2. Like the height of the graph above the middle is still 2. So be careful with amplitude. Amplitude's always positive. Negative flips it over, like always. Flips it over the x-axis, or flips it in the y direction. Maybe a better way to say it. Again, these are transformations that you're kind of going quick, but you know the transformations. Now we're trying to apply them to the new graphs that we learned yesterday. As with other parent functions, we can shift the graph left right or left, up or down. And it works the same way as all the previous transformations. So this looks complicated, but we kind of know all the pieces already. A controls the amplitude. If it's minus h, that shifted h to the right. Remember, the sign is backwards for the x stuff. So if it's x plus 2, which way does that shift it? That's a left 2. So all your shifting rules, your up, down, left, right rules are the same. X minus 3, which way would that shift it? Right 3. And then the k on the end shifts it up or down. Now be careful, k, when it shifts it up or down, you can think of k as the midline. K tells you where that middle is. The sine or cosine does the oscillating, but k moves the whole thing up or down, so k shifts the midline up and down. Tangent, cotangent, secant, cosecant, they work all the same way. You don't call it an amplitude. They're not waves, so you don't get to call it an amplitude, but it still does the same thing. It stretches it. And then the left-right shift, the up-down shift. That's the thing about parent functions and transformations. Once you know how transformations work, you can apply it to any parent function. So whether it's parabolas, lines, ellipses, it doesn't matter. If it's in there with x, it controls it in x like it always does. If it's not in there with x, if it's out by itself, it's an up and down control. Let's see if we can put some of this to use here. So y equals 3 sine of x. Okay. First thing I'm going to do is do a quick little parent function of sine of x. So my brain knows like what I'm starting with. So that's not the full official nice one, but that's what sine looks like. What does that 3 do to the graph? What does the 3 do to the graph? Stretch it. Okay, so we're going to stretch it by 3. It's going to change the amplitude to 3. So where am I going to start my graph? Where does sine start? 0. If I stretch that by 3, where does it go? That's a bit of a trick question. It doesn't, right? If you multiply 0 by 3, you're still at 0. It's still there. You stretch it, but if you're at 0, you didn't get stretched anywhere. Now I'm going to kind of mirror my, or follow the path of my parent function here. I'm going to go to 2 pi and put my ending point on, because that didn't get stretched either. Halfway in between there, I'm still on the midline. That wouldn't get stretched at pi. It's the maximums and minimums that get stretched. So normally this point is at 1. I'm just going to call it point A. Where does that point go if I've stretched it by 3? Like up to 3. 3 times 1 is 3. So here's my sort of new A, A prime, I guess we can call it. This bottommost point, this minimum point, I'll call point B. If I stretch it by 3, where does it go? Down or up? Down, so there's my new point B. It's like, whoa, that looks different than the ones we've drawn before, but it's supposed to look different than the ones we've drawn before because we stretched it by 3. It does say to graph it from negative 2 pi to 2 pi, but that's not a big deal. Now I take what I just drew and sort of extend it backwards. So I start at 0, the halfway point's at 0, and there's a max and a min. That's a pretty good looking sine wave. Number 2. What's the negative 3 going to do? Should be 2 answers to this. Flip it and stretch it. And again, just out of habit, I'm going to put the parent function, just a quick little parent function on there, so that my brain thinks, oh yeah, cosine, I know what a cosine looks like. Now I need to adjust it, but I need to have a starting point. And I think if you try to do it without drawing that little picture, there's too much going on in your head at once. So draw the picture, then we can flip and stretch it. So normally we start at 0, 1. That's our normal starting point for cosine. Where's that point going to be after I flip it and stretch it? Negative. Okay, negative, yes, but I'm going to stretch it. So I'm not moving it down 3. I'm stretching it by 3. So it's going to go to negative 3. So we'll stretch it, flip it, and stretch it. And then I like to do the last point next to sort of set, the window, the period. So the last point would be that point. Point B, where's that point going to go after I flip it and stretch it? This point, if I flip it, it's going to be the same as A, so it moves down here. Then I'll do my middle point, which used to be at a minimum, but when I flip it, it becomes a maximum. So it's going to be all the way up here now. And halfway in between, it's on the midline. Okay, this looks like a giant upside down V, but remember, there's curvature here. It's a wave. And then after you do one cycle, see if what you drew matches what you said. Right? That's always a good check on parent function transformation stuff. Flip it and stretch it. Yeah, it flipped over and we stretched it out. Now let's copy that back a cycle. So back at negative 2 pi, we're down in the minimum. Halfway, we're at a maximum. Halfway in between there, we're at the midline. And then we'll neatly, carefully sketch in the rest of it. Okay, flips and stretches. Not too bad, but that's only one transformation that we've done. Let's try some different transformations. A horizontal shift is also called a phase shift. So, or a left-right shift. Now, it doesn't really matter what you call it. It still works the same way. So let's start at number 3, and then we'll talk about this. Make a little plus sign. What in the world that means? So let's just take them in order. What's the negative 2 going to do? Stretch and flip. So they got a flip and a stretch. How about the minus pi over 2? What's that do? Going to go right pi over 2. This one is a little tricky. Whenever you have a phase shift, you got to make sure you shift your whole perspective right or left, and we'll talk about how to do that in a minute. And then the plus 1, what's that do? It's up 1. Okay, this is a great hint right here. When you have a horizontal and or vertical shift, make a little plus sign where your new origin is. So I'm going to go right pi over 2 and up 1. Sometimes I'll do it with a highlighter so I can see it better. But that's sort of my new origin. Not sort of, it is my new origin. And if I'll base everything off of that starting point, then I don't really have to account for the pi over 2 and the plus 1 anymore, because I just shifted the whole thing and I'm going to start there. And so I don't have to worry about those two transformations anymore. Okay, let's see. A sine, I know what a sine looks like. Do my little bitty mini parent function to know what my graph should look like. So I normally start at the origin. So if I call that point A, then my new starting point is at the new origin. I've gone right pi over 2 and up 1. There's my new starting point. Now let's jump to the end. Point B. What's the window? What's the width? What's the period from A to B? What's the period of one cycle for sine? 2 pi. So be careful. That means I don't end at 2 pi. It means I end 2 pi away from where I started. So this is where we have to be careful, especially when the graph doesn't show it very well. My ending point is not 2 pi. My ending point is 2 pi away from A. So I don't want to go to 2 pi. I want to go pi over 2 past 2 pi. And so my ending spot, again, my window is 2 pi away. Because that's one period or one cycle. That is a super common mistake, is to say, oh, the period's 2 pi, so it starts over at 2 pi. No, it starts over 2 pi away from where you started. So I've got my starting and my ending. Now it's, if you get that far, you're probably fine. You just put the pieces in there. The middle point would be right there. There's a maximum. Although I need to be careful, because that maximum right there has been flipped and stretched. So it becomes a minimum. And how far away from the midline is it going to go? 2. 2 away from my midline. So it's down here. Not at -2. Because it doesn't mean go down, well, I guess it means go down 2, but it doesn't mean go down 2 from the axis. It means go down 2 from the midline. And then kind of the same thing with my point that was right there. It's going to get flipped to the top and stretched. So it needs to go 2 up from the midline. We okay with that? So I've got a sine graph. It's been flipped and stretched and moved right 2 and up 1. So like almost everything you could do to that graph to mess it up, we did it. Although my instructions say graph it from -2 pi to 2 pi. So now I need to take this picture and extend it backwards. So probably the easiest thing to do is to just follow the pattern. Okay with that graph? We're going to talk about this later, but if you didn't have this, you just looked at that graph, what kind of graph would you think that is based on how it looks? Maybe it's too soon to ask this question. Like, there's my origin. To me, it looks kind of like a cosine graph because it starts at a maximum. But that's because we've shifted things around. And so when you look at a graph, and we'll do this next week, when we want to write the equation of this graph, there's several different ways to do it. You could say it's a sine graph that started where we started, or you could say it's a cosine graph that started kind of on the origin. That's more for later, though.
Why did you go with extra?
Okay, so that's a really good question. I'm going to do that thing where I highlight there's my first cycle. But the instruction told me to graph it from negative 2 pi to 2 pi. So I went further than I needed to, but I kind of had to get my full picture in there. And then on the back end, like a second cycle would have stopped there, but it told me to get to negative 2 pi, so I just extended it a little bit more. So that's a good question. I graphed more than 2 cycles, but I had to follow the instructions. Number 4. Let's start picking on people here. Fun part. Emma, you got a stick now, so you can play along with us. Didn't want you to be left out. So Emma, how about that 2? What does that do to the graph? Stretch it. Good. Joseph, how about the plus 3/4? What's that going to do? Good. Left 3 pi over 4. Again, these are things that we kind of already knew. We haven't graphed sines and cosines, but you guys are really good with translations. Evan, how about the minus 1? Down 1. Okay, good. Again, I'm not worried about the translation part. I know you know how to do that. Now it's, can we put this picture, can we apply all of those things to our cosine graph? I'm going to go ahead and do my little baby picture there so I know what I'm looking at. Okay, left 3 pi over 4 and down 1. Ooh, 3 pi over 4 is not even on the graph, so I got to know where it is. And down 1. So there's my new starting point, my new origin. The nice thing about finding the new origin, though, is now I don't really have to worry about the 3 pi over 4 and the 1 because I already handled that. All right, so point by point, cosine usually starts up 1 from the origin. Where is my new graph going to start? Up 2 from where? From my new origin. So I'm still going to be at a maximum, but my maximum is going to be 2 up from my new origin. So there's my new starting point. My ending point will be at the same height as the starting point because it's got to end where you start. It's got to be 2 pi away. So I got to figure out how do I get 2 pi away from negative 3 pi over 4.
So if it doesn't, just say your point doesn't go all the way to 2 pi, you have to do another one so when it's past it.
Right, since it tells me to graph past all the way to 2 pi, yeah, my first cycle is not going to get to 2 pi. It's going to come up 3 pi over 4 short. And so I'm not worried about this part of the instructions yet, but you're right, I will have to extend it to the right a little bit more to get there. But right now I'm trying to figure out where does this thing end. If I start at negative 3 pi over 4 and I go 2 pi away, Well, maybe some fraction work.
In between the pi and the 3 pi.
Yes. How did you get there? So,
I just did it.
so it does end here. In fact, some people will put like a little smaller origin there, because that's not my new origin, but that's the window I need to fit it in. So a couple ways to do it. You could start at negative 3 pi over 4, add 2 pi, you get 5 pi over 4, put you right there. That's sort of the most direct way to go. There's some sneakier ways to get there. So from my origin, I went left 3 pi over 4. So that means from my usual ending spot, I could go left 3 pi over 4. I don't know if that's helpful or not. 0 to 2 pi is 4 grid spaces. Here's another way to do it. So I need to go 4 grid spaces away. 1, 2, 3, 4. So there's at least 3 different ways to figure out where your ending point is. Alright, so A and B are maximums. I'm going to say point C is the minimum. Where is point C going to go? Well, here's the halfway spot. But how far up or down is it going to go? Down 2 from the midline. So there's my midline. I'm going to go down 2. It'll be right there. And then my zeros, well, they're halfway between the max and the min, so they are on the midline and on the midline. Man, this is a weird one because it's not, the points aren't at grid intersections. But there's my cosine graph. And again, once you draw the first one in, check it against what you said would happen. Stretched, yep. Left 3 pi over 4, down 1, yes. Now, I got to continue the pattern to get from negative 2 pi to 2 pi. So,
You don't need to go past 2 pi. That's what I was really asking. Like, could the point you just added, right, it doesn't go all the way to the point.
So I really didn't get to 2 pi. I guess I haven't officially answered this question completely yet until I put one more point down there, and then I go past 2 pi. Same thing on the other side, if I really want to make sure I go through 2 pi. Let's do a couple of tangent ones. We did not graph tangent earlier, so let's do a quick tangent sketch. The tangent of 0 is 0, and I remember what it looks like, and I know there's asymptotes there, and the period is pi. So I can hopefully sketch the parent function for memory. Now we're going to do some changes to that parent function. Uh-oh. You got this, Audrey. You probably already even know what I'm going to ask, Audrey. What's the answer to the question that I haven't even asked yet? See if you can read my mind. What do you think I'm going to ask? Is that too hard of a question?
Yeah.
Not even asking a question?
Left pi over 2.
Look at that. Yes. Left pi over 2. Cole, what's the answer to the question that I'm not even going to ask you?
Down 1.
Down 1. So left pi over 2, down 1. That's going to be my new origin. Left pi over 2, down 1. The instruction said put a little plus there. Some people go overboard, and they're like, forget the little plus. That's my new origin, baby. Let's go. And so they put the full thing on there, and that's fine too. Nothing wrong with that. If that helps you sort of recenter your brain, that's my starting point, then go for it. Okay, so tangent starts at 0. There's a point at my origin. So now there's a point in my new origin. My asymptotes. Oh, what did I do wrong? Left. I went to the right. I'm supposed to be going to the left. I wonder if I will be okay.
You will.
I will. I got lucky that it all worked out. Oh, I wish I hadn't done the full origin thing, like I was making a silly scene doing. Why am I regretting doing the full X and Y axis there? Do you know? You're right, because I want to put my asymptotes to look like that. Now I'm going to have a messed up picture. Alright, so there's my real new starting point. So pi away, I have another 0, and pi away, another 0. So for tangent, if you get the zeros and asymptotes, then you're going to be fine. And the asymptotes are always halfway in between the zeros. I guess maybe the important question is, how did I know to go pi away to get to my next 0?
That's how long it is, right? That's the column is just.
Yep. What's the word we're looking for there?
That's just how long
A period.
That's the period. So every pi, it repeats itself. So that means every pi, there's a 0.
Wait, and how do we know that?
Because the period for tangent is pi. You have to know that. Yeah, the period for tangent is pi.
So there's only one point on it?
Yeah, for tangent, there's only one point I have to see, like one key point. Sine and cosine, there's 5,
Yeah.
right? But for tangent, there's only one key point, but there are the asymptotes. So if you get the zeros and asymptotes, you'll be okay. Man, I messed that up doing that full thing there. Number 6. Let's see. Angel, what's different? Like number 6, the parent function is tangent. How is number 6 different than the parent function? What's been changed? Okay, it's flipped. Okay, that's going to be maybe tricky to flip tangent. Maybe not. If I flip tangent, what will it look like? Go the other way. Look maybe a little bit like cotangent. Toby, what's that -1 do to my graph? That -1. Down 1. Oh, I don't have a left-right flip, but I have a flip and down. I'm back to the little plus so I don't mess up my asymptotes again. Let's see, that's my new axis. Even though I just did a tangent, I'm still going to do a quick little picture what tangent normally looks like. So I know there's usually a 0 right there. How far away is my next 0?
5.
How did you know that? Yes, because I just told you. The period is pi, so it repeats every pi. So there's zeros every pi away, or every pi from each other. What's going on in between the zeros? It's an asymptote. In between my zeros, I have an asymptote. And then I'm ready to sketch the graph, but I better be careful, because what's different about this one that I haven't really accounted for yet? It's flipped. So rather than increasing, it's decreasing. Today is when you put together two things. The parent functions, which again we only learned yesterday, so that's tricky. And then transformations. Transformations you're really good at, but it's hard when you're putting them on a graph you're not sure about. Number 7. State 4 equations for the graph below. Okay, I don't know that we'll get to 4 of them. What shape does that look like to you? What? Cosine. I like that. So let's say it's cosine. Regardless of sine or cosine, I do know where the midline is. At -1. So I know I'm down 1. I know I'm down 1. That'll be regardless of whether I choose sine or cosine. What else is true whether I choose sine or cosine? The stretch or the amplitude is 2. So for me, I think the easiest equation would be if, like you guys said, this is a cosine, and that means that would be my starting point. So there has not been a left-right shift, and it's not flipped. So 2 cosine of x minus 1. Right, that would be the easiest way to describe that graph, I think. What if we want to use a sine? Where would you say it starts if we want to call it a sine? Yeah, careful. I'd say negative pi over 2. So that's left pi over 2. So I still need the 2 to stretch it. If I'm going to go left pi over 2, then how do I accomplish left pi over 2 to get to here? X plus pi over 2. And then is that it? Yeah, the minus 1 to move the whole thing down 1. Are there other places I could have said it started? Okay, we're going to be tricky if we go to positive pi over 2. If we go right pi over 2. So what's different if we want to start at right pi over 2? It's flipped. So I can go x minus pi over 2, but it's flipped, so negative 2. Now, if you get to pick one, you're probably going to pick this one. But this is to illustrate that there's an infinite number of ways to describe that graph. Right? If you really wanted to get crazy, you could come over here and say, well, there's my starting point. I'm not going to do it, but would that be a sine or a cosine? Be a cosine. Because sine has to start on the middle. If we're starting at a minimum, so how would I accomplish that? Yeah, it'd have to be negative. So that would be negative 2 cosine x. Yeah, it is being too crazy. X plus 3 pi. And then the minus 1. we're going to let you pick which one you want. This is just to illustrate that there's a million, literally more than that, ways to describe that graph. Because, you could start it at any max or min or 0. And you just have some different combination of left-right shift and whether it's negative or positive. The same thing down there at number 8. So we're not going to do number 8. I do want to write this because this will sort of lead into the Desmos activity. So write that down, and then we're going to talk briefly about what each of those are. Well, you know what most of them are. What does A control? The stretch or the flip. Stretch and or flip. B we don't know yet. C is the phase shift or the left-right shift. And D is the vertical shift, or we'll just say up-down shift. B is a little bit tricky, so we're going to hold off on B until tomorrow. What we're going to do next is go to Schoology. If I can find where I put it. Well, there's people's grades. That's not good. Oh, I've got to get to Schoology without looking at grades. Okay, so I gotta have to pause this. All right, so look at Schoology. That's what it looks like when you get into Schoology. We're in Unit 9. And then first period Desmos activity, that's the one that you will pick. First period. 7th period, you're watching the video, you'll pick 7th period Desmos activity. So pick that, get started, and I will see you tomorrow.